Hello everyone. So today we will start with the another chapter of inorganic chemistry of 12th class, that is D and F block elements, right? So we will just have a introductory part today. See, particularly we have studied about S block elements in class 11, and P block we have studied that it is having from group 13 to 18, amongst which 13 and 14 we have studied in 11th class, and 15th and 18, 15 to 18 group particularly we have completed in the previous chapter, that is P block. And S block consists of basically group 1 and group 2. So this all we have done. Now we are left with the middle of the S block and P block, that is the D block. And at the end of the periodic table particularly, you will find out that two series are separated here, which are known as F block elements. So we will study in detail about the D block elements and the F block elements, and this will complete your study of the whole periodic table. Okay, so let's start with the session now. See, here you can see that these are known as S block elements because the last electron enters in the S shell and S subshell, and here from 13 to 18 are known as the P block elements, where the last electron enters into the P subshell, and in between are the D block elements that are from group 3 to group 12. So these are known as the D block elements because in them D orbitals are progressively filled, right? So you can see that 1, 2, 3, 4, 4 periods are present in the D block. This is known as the 3D series or the first transition series. This is known as the 4D series or the second transition series. This is known as the 5D series or the third transition series, and this is known as the 6D series, that is the fourth transition series, right? And one important thing here is that 3D, 4D and 5D, you have to remember the electronic configurations as well as the name of the elements too. But from 89 to 112 particularly, if you are seeing here, the 6D series, that is not important from our examination point of view, so you can skip that part. However, if you wish to learn, you can learn them also. And these in the end are two F block series in which 4F subshell is filled and 5F subshell is filled. So this is known as 4F series and 5F series respectively. 4F series is also known as the lanthanoid series and 5F series is also known as the actinoid series, right? So all the elements of the actinides particularly, if you will see that they are radioactive elements, and after uranium all the elements are known as transuranium metals. Transuranium elements or metals. Okay, so this was all about the position of the F block and the D block elements. Yeah, so here you can see that 21, 22, 23, 24, 25 and so on till 30, then 39, 40, 41 and so on till 48, and then 57, 72. See, here is a skip of particularly, if you will see, 14 elements. So particularly on jumping from 57 to 72, the middle elements are the F block series that are separately placed here. Similarly, for this also 89 to 104, there is a jump in the atomic number because the in between elements are placed in the actinoid series, right? They are separately placed because first reason was that they were lately discovered. Second reason was that they were not matching the properties of the respective groups and periods. So basically they were separately placed from the periodic table, known as the F block elements. Now we have to learn particularly that how to easily memorize the D and F block elements. So first we will begin with the 3D series, that is also known as the first transition series. So the elements are scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So we are having two mnemonics here. Science teacher Vidya Krishan and manager Firoz could not cut zinc. So either this way you can remember, or you can remember second hand titanium vanadium crashes more number of times than Fevicol, nickel and curtain zip. So this is scandium, titanium vanadium, chromium, manganese, then iron, then cobalt, then nickel, and then copper, and then zinc. So in this way you can also remember the elements of the 3D series. Next you consider the 4D series. So you can remember it as yes, zero, nobody, most teachers, rechecked, Raghavan's paper, again to confirm. So this is yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver and cadmium. Yes, zero, nobody, most teachers rechecked, Raghavan's paper, again to confirm. Next is the 5D series. So this you can remember it as Luftwaffe taken warring rebels out of Ireland, Poland, Australia and Hungary. I'll again repeat. Luftwaffe taken warring rebels out of Ireland, Poland, Austria and Hungary. So this is Lu, this is hafnium, this is tantalum, then tungsten, then rhenium, then osmium, then iridium, then platinum, then gold and then mercury. So in this way you can remember the 3D, 4D, 5D series as well. Now next is the 6D series. So 6D series you can have it as actually R.D. Sharma book has math difficult sums. So R.D. Sharma is basically a book that we solve for maths. You must be knowing it. You must be familiar with it. So basically you can remember it as actually. See, this is the same Rutherford which has invented the Rutherford model of an atom. R.D. Sharma book has math difficult sums. Okay. Next, how to easily memorize the F block series. So F block we are having two series, that is the 4F series and the 5F series, right? So 4F series you can remember it as last century presented new democratic prime minister including Shri Modi, right? So this is lanthanum, cerium and so on till SM. Then European government decided to ban dirty hotels. Everyone to make yellow barley for lunch. Again I am repeating. Last century presented new democratic prime minister including Shri Modi. European government decided to ban dirty hotels. Then everyone to make yellow barley for lunch. Barley for lunch. Right. So this is thorium and this is lutetium. Next, 5F series. Thor protects Uranus, Neptune and Pluto. So this will be Thor protects Uranus, Neptune and Pluto. Then next is America cured Berkeley in California. Einstein, Fermi and Mendeleev are Nobel laureates. Right. So this way you have to just remember, see, actually you don't have to remember the names for the 4F and 5F series. You can just remember the mnemonic and you should know the symbol. This is very important. You should know the symbol particularly, right? So what you have to do is to remember the mnemonics first and then write down the symbols for different elements using the mnemonics. Next we come on to the D block electronic configurations. So first series we will study about the 3D series, right? So you can see the configuration as 4s to 3d1, 4s to 3d2, 4s to 3d3, 4s1 3d5. Now this is because of, this should be 4s to 3d4, but because of the stability of the half filled subshell this becomes 4s1 3d5. Then manganese, it is 4s2 3d5, 4s2 3d6, 4s2 3d7, 4s2 3d8, 4s1 3d10. Again this should be 4s2 3d9, but it is 4s1 3d10 due to the stability of half filled and the fully filled electronic configurations. Next it is 4s2 3d10. Now you come on to 4D series. Basically, if you will see that there is a difference between the 3D series and the 4D series. So instead of learning the whole series, I will recommend you to kindly learn these particular configurations. Although it is good that you remember all the configurations, but palladium, silver and cadmium is the must. So this will become 5s2 4d1, 5s2 4d2, 5s1 4d4, 5s1 4d5, 5s1 4d6, 5s1 4d7, 5s1 4d8, 5s0 4d10, 5s1 4d10 and 5s2 4d10. So these you have to remember. See, basically you are having the electronic configurations as different because various factors like nuclear electron and electron-electron forces and stability of half filled and fully filled orbital happens here. Okay, so each configuration we cannot give a explanation particularly, like that you can learn in the higher classes, but you need to remember the electronic configurations which are specially different due to the half filled and the fully filled orbital. Next you come on to third series, that is the 5D series. So this will mean be 6s2 5d1, 6s2 5d2, 6s2 5d3, 6s2 5d4, 6s2 5d5, 6s2 5d6, 6s2 5d7, 6s2 5d9, 6s2 5d10 and 6s2 5d10, 6s1 5d10 and 6s2 5d10. So here also platinum, gold and mercury, you have to remember the electronic configurations as well. Then comes the fourth series, that is the 6D series. This will be 7s2 6d1, 7s2 6d2, 7s2 6d3, 7s2 6d4, 7s2 6d5, 7s2 6d6, 7s2 6d7, 7s2 6d8, 7s1 6d10 and 7s2 6d10. Right. So again, I am repeating that fourth series is not important from our examination point of view, but you have to learn the first, second and the third series, especially with their respective electronic configurations. Next, basically, the D block elements are called transition elements. See, why are they called transition elements? Because from transiting from S to P block, we have to go through the D block, right? So that is why it is known as transition elements. So first we will define that particularly what are transition elements, what is the definition of transition element, right? So transition element is the one basically in which incomplete d orbital is present. That means the d subshell should be incomplete either in its one of its common oxidation state or in the ground state. For example, let us say nickel, right? So nickel is what? 4s2 3d8. So it is having d subshell incomplete, right? Copper you take, copper is 4s1 3d10. Here it is having a d subshell fully filled, but in its oxidation state, for example, copper 2 plus we are taking, it is having d9, that means incomplete d subshell. Therefore, it is a transition element. But you come on to zinc, cadmium and mercury. These are not transition elements. They are d block elements, but they are not transition elements. Why are they not transition elements? Because these exhibit a oxidation state of +2. Zinc is having an oxidation state of +2, right? In +2 oxidation state also, the D subshell is completely filled. For example, zinc is having the electronic configuration as 4s2 3d10, right? Now you come on to +2, so this will become what? D10. Again the subshell is completely filled. So that means they are not transition elements, but they are post-transition elements, because neither in their oxidation state the D subshell is incompletely filled and nor in their ground state the D subshell is incompletely filled. Now, how do we write electronic configurations of cation? For example, you say copper 2 plus, right? First, you write down the electronic configuration of the ground state. So, copper is what? 4s1 3d10. So copper 2 plus will be what? You have to first remove the electrons from the outer orbit. Now amongst the principal quantum number third, that is orbit number 3, and the principal quantum number 4, that is orbit number 4, which one is far from the nucleus? That is the orbit number 4, right? So removal of electron from this orbit will be more easier because it gets less nuclear charge due to the nucleus, right? So here you will see that this will first go, 4s will first go, and then you will remove electrons from D. So this will become what? 1 electron from this, 1 electron from this. So this will become 3d9. We will have one more example. For example, we are having Fe3+. So first you will write down the ground state electronic configuration of iron, that is 4s2 3d6. Now 3 plus means 2 electrons from this and 1 electron from this. So iron 3 plus will become what? 3d5. Okay. Next is the lanthanoid and the actinoid series. I have already explained that lanthanoid are 14 elements that are starting from 58 to 71, and then actinoids, if you see, 14 elements again which are starting from 90 to 103. In this 4f subshell is filled and in this 5f subshell is filled. So lanthanoids are also called rare earths. They are not called rare earths because they are rare in nature, but actually they are found in the nature first in the form of their oxides. They are very much abundant, but they are abundant in the form of their oxides. That is why we call them as rare earth metals. Now see, we have to remember the electronic configuration of F block, which is very much important. Question will come from F block from the electronic configuration only, right? So here you have to see that in 4F series, in the 4F subshell is filled, 5D is filled, and 6S can be filled. So the general electronic configuration is that 4F subshell can be filled from 0 to 14, 5D can be filled from 0 to 1, and 6S can be filled, that is 2 electrons it will be occupying, right? Now here the difference is that some of them are having 5D1 filled and some of them are not having 5D1 as filled, right? So there is a way to remember particularly. See, cerium starts from 4F1, 5D1, 6S2. So cerium you have to remember, then you have to remember this gadolinium, this one GD, and then it is lutetium. So only these three are having 5D1 electronic configuration. Except these three, all of them are having missing 5D subshell, right? So here it will be 4F1, 5D1, 6S2. Because it is not having FD, so this electron will also be counted in 4F only, right? So one electron is adding up, right? So this should become what? Actually 4F2, 5D1, 6S2, right? But it is the 5D electron goes into the F only, so this becomes 4F3, 6S2. Then it is 4F4, 6S2, 4F5, 6S2, 4F6, 6S2, 4F7, 6S2. Then again, due to the stability of the 4F7 being the half-filled subshell, the extra electron goes into 5D. Then again 4F9, 4F10, 4F11, 4F12, 4F13, 4F14, and then due to the fully filled stable configuration of F subshell, you are having 5D1 again. So these you have to remember. Again, for actinoids, you have to remember that 6D subshell is filled for thorium, for Pa, for uranium, for curium, from lawrencium and rutherfordium. So these are having 6D subshells as filled and other of them are not having 6D subshells as filled, right? So you can just jot down the configurations and then we will move on to the next slide. Yeah. So next we will have the general electronic configuration. You can remember that 5F is having 0 to 14. 6D can have 2 also, 1 also and 0 also, and 7S2 is already there. So basically the filling of atomic orbitals, if you will take, see, this is the valence shell, then this is the penultimate shell, and this is the anti-penultimate shell, right? So when you are filling the d block elements, particularly you are filling up the penultimate shell, and when you are filling up the f subshell, then it is the anti-penultimate shell, and therefore they are known as inner transition elements, because the anti-penultimate shell is being filled, which is inner of that of the penultimate and the valence shell. And this I have already told you that uranium is basically having atomic number 92, and after 92 the elements which are man-made, these all elements are man-made, right? So these are known as trans uranium elements.